All right, let's get right into it. Today, we're going to tackle a massive point of friction in modern engineering, that constant struggle to really understand these complex three-dimensional designs when you're stuck looking at them on a flat 2D screen. Turns out there's a real, measurable cost to this, and a surprisingly elegant solution.
So, what is the hidden cost of reviewing these incredibly complex 3D models on a flat screen? We've all done it, right? You're panning, zooming, rotating, trying to build that true 3D picture in your head. But what's that really costing you? It's more than just time. It's a tax your brain is literally forced to pay.
And that brings us straight to the heart of the issue. We call this hidden cost the cognitive tax. Think of it as the extra mental horsepower your brain is forced to burn when it's being deprived of the one thing it needs to truly understand space: actual depth.
So what exactly is this cognitive tax? Simply put, it's the mental price you pay to translate a flat image back into a real, coherent 3D model inside your mind. Every single time you do this, you're spending precious mental energy that should be going toward actual engineering judgment. And the result? You get tired, your chance of making a mistake goes way up, and your decisions become slower and less confident.
Now, here's where it gets interesting, how this tax actually gets paid. As you can see here, you're not just looking at a model, you're performing a full-on mental workout. You have to mentally rebuild the 3D space, guess at distances, imagine if someone can even reach a certain valve, and all the while, you're constantly spinning that model in your mind's eye just to get a complete picture. It's exhausting.
Yeah, that constant spinning, it actually has a name: mental rotation. And make no mistake, for your brain, it is a very demanding computational task.
And look, this isn't just a clever metaphor. This science backs this up. fMRI scans show that mental rotation heavily uses specific parts of the brain, especially the intraparietal sulcus, or IPS. Now here's the crucial part. This is the exact same part of the brain you need for high-level spatial reasoning and problem-solving. So, the very tool you're using is taxing the precise mental resource you need to do your job well. How crazy is that?
So if 2D screens are hitting us with this big tax, how do we stop paying it? Well, this is where everything changes. It's all about how VR eliminates that tax by shifting our brains from a state of just guessing to a state of direct perception.
And this table just lays it out perfectly. On a 2D screen, everything is an inference, a guess. You're guessing depth from shadows, you're guessing scale from abstract numbers. But in VR, it's a whole different world. Depth is something you just perceive. Scale is something you feel relative to your own body. Your memory of the space is based on walking a path, just like in the real world. The result is simple. Ambiguity just plummets.
Let's break that down. First, and this is probably the biggest one, is true binocular depth. The question, wait, is that pipe in front of or behind that beam? It just vanishes. Your brain doesn't have to calculate it. It just knows instantly. Second, you get what's called embodied navigation. You stop flying a camera around with a mouse, and you actually start using your feet. You physically walk the maintenance paths, you duck under the pipe racks, and you look around corners. This taps into your brain's natural, deeply wired navigation systems, which makes the layout feel intuitive right away. And third, you can make full-body judgments. Can an operator actually reach that valve without a ladder? Is there enough clearance to turn a wrench? In VR, you don't have to guess. You can literally reach out your own hand and check for yourself. And suddenly, all these ergonomic and accessibility problems become glaringly obvious.
So the most crucial point is this. It's the difference between guessing and knowing. Like the slide says, VR lets you feel distances, not just guess them. And that fundamental shift is what completely eliminates the cognitive tax. Okay, so that's the science, but what does this actually mean when you're out in the field? Let's look at some real-world use cases, especially in human factors engineering and complex industries like oil and gas, where these details have massive, massive consequences.
I mean, look at this list. These are exactly the kinds of expensive and, frankly, dangerous mistakes that are so easy to miss on a 2D screen. But when you're immersed in VR, they become impossible to ignore. Blocked escape routes, impossible maintenance access, crane path conflicts. These are the million-dollar issues that VR helps you find at the cheapest possible moment before a single piece of steel is ever cut.
And let's be super clear, this is not science fiction. This is mainstream engineering practice today. Industry leaders like Shell and ExxonMobil are already using immersive platforms like VREX to run multi-user design reviews, to validate constructability, and to simulate operations long before they even think about breaking ground.
So,
We've gone from the neuroscience to the real-world application. Now let's connect all of it to the one thing that every project manager and executive cares about, the bottom line. How does eliminating a cognitive tax translate into cold, hard cash?
It all starts with a classic principle in engineering and quality control that I'm sure many of you know very well, the 1-10-100 rule.
The rule is simple, right? It costs $1 to fix an error you find in the design phase. It costs $10 to fix it during fabrication, and it costs $100 or much more to fix it once it's in the field. By getting rid of that ambiguity and making errors obvious from the start, VR is one of the most powerful tools we have for finding those clashes and ergonomic nightmares at the absolute cheapest, $1 stage.
And that focus on catching things early leads directly to these business outcomes. You get way fewer late-stage change orders, the things that just kill project budgets and schedules. Rework costs plummet. Stakeholders, from the engineers to the operators who have to live with the design, get on the same page much faster because they are literally standing inside the same reality. This accelerates your key design gate decisions, and most importantly, it results in safer, more operable facilities right from day one.
So, we'll end with this thought. For millions of years, your brain has evolved to understand and navigate a three-dimensional world. It is a finely tuned spatial processing machine. So the question is, isn't it time your engineering tools finally caught up?